In this video, we are talking about the law of total probability. In this case, we are going to consider a set of mutually exclusive and exhaustive events. So what means that are mutually exclusive is that the intersection of all of them is empty. So we observe the events on the right hand side. We can see that A1, A2, A3, which are our events, are not intersecting. So the intersection is 0. And the second word, exhaustive events, means that when we add all the events, they are equal to the sample space S and is conformed by the union of all of this. So therefore, the sum of the probabilities of all these events is equal to 1. Then let's consider an event B. So let's say this is B. So the intersection with B, with all different events, is equal to the probability of B. So we know the probability of B is all this region, and that region is given by the intersection. So if we intersect with all of them, including this one, in this case the intersection is going to be empty, so the probability is 0. But eventually we have, this is the probability of B with A5, the probability of B with A6, the probability of B with A8, and the probability of B with A9. So that will form the probability of B as the sum of the probability of the intersections with our mutually exclusive and exhaustive sets of events. Now remember that for future reference, we can describe the intersection in terms of a conditional probability. Remember that this guy, for example, can be written as the probability of B given A multiplied by the probability of A. Now let's have an example. So how can we use this result? So in this example, we have 3 bags, and each one of these bags contains 100 marbles. Now the marbles can be blue or can be red. So in the first bag, so let's say that this is the first bag, B1, the second bag, B2, and the third bag, B3. So in the first bag, we have 75 red and 25 blue marbles. So we can say that the probability of red, given that we are in the bag number 1, is equal to 0.75. So remember that the total number of marbles is 100, so 75 divided by 100 is 0.75. The same way in the second bag we have 60 red and 40 blue, so the probability of having a red, given that we select bag 2, is equal to 0.60. And finally we have that the probability of selecting a red, given that we choose bag number 3, is equal to 0.45. Now if we select one of these bags randomly, so we can also say that the probability of selecting bag 1 is 1/3, the probability of selecting bag 2 is 1/3, and the probability of selecting bag 3 is 1/3. So we have 2 different events. One is selecting the bag, and the other one is choosing a marble from that bag. Now, if I choose one of the bags at random, so that means with probability equal to 1/3, and then pick a marble from the chosen bag, what's the probability that the chosen marble is red? So now by the law of total probability, we have that the probability of selecting red is equal to the probability of selecting red intersection with bug 1 plus the probability of selecting red intersection with bug 2 plus the probability of selecting red intersection with bug 3. Now, how do we compute these intersections? Well, this intersection, remember that we can write always this probability of the intersection in terms of the conditional probability. So the probability of selecting a red given intersection with bug 1 is equal to the probability of selecting red given that we choose bug 1 multiplied by the probability of B1. So that's just the definition of the conditional probability for the first case, plus we can do the same thing for the second case. So the probability of selecting red given that we choose bug 2 multiplied by the probability of bug 2. And finally, the third one is the probability of selecting red given that we are in bug 3 multiplied by the probability of selecting bug 3. Now we have all this information. So the probability of selecting red one that we are given that and we are in bug 1 is 0.75 multiplied by the probability of selecting bug 1 is 1/3 plus in the second case is the probability of selecting red one given that we are in bug 2 is 0.60 multiplied by the probability of selecting bug 2 which is 1/3 plus the probability of selecting a red one given that we are in bug 3, that's 0.45. 0.45 multiplied by the probability of bug 3, which is 1/3. So if we do all these mathematical operations, we have that this is equal to 0.60. Okay, so remember, the question is what is the probability of selecting the red one? So what we did in this particular case was choosing this set of the red ones, and we intersect with bug 1, with bug 2, and with bug 3. Now we can extend further by defining the Bayes rule. Now let's consider two events, A and B, and the probability of A is different from 0, the probability of its complement is different from 0, and also we have another event, B, whose probability is different from 0. So we can write the conditional probabilities of A and B, A given B and B given A in the traditional form. So that's equal to the probability of the intersection divided by the probability of B. And in the second case, we just swap it. So that's the probability of intersection. Then remember that the intersection is commutative divided by the probability of A. Now, if we just replace this intersection by the definition in here, so let me write the definition in the second case. So probability of B given A multiplied by the probability of A is equal to the probability of the intersection, so the probability of B intersection with A. And because this is commutative, so I can replace that value in this equation. So let me take this equation. So the probability of A given B is equal to the probability of the intersection and I'm going to use the result of the right hand side. So that's equal to the probability of B given A multiplied by the probability of A and divided by the probability of B. So this is the Bayes rule. The Bayes rule allows us to write a conditional probability in terms of the opposite conditional probability and multiply by the probabilities of the two sets A and B. As usual, in this rule we divide by the probability of B. Now we can further extend this result. So this is, remember, this is Bayes' rule. If we use the law of total probability to write the probability of B. So we can write the probability of A given B equal to the probability of B given A multiplied by the probability of A, and the denominator we can use Bayes' rule. So we have to the law of total probability. So we have to find a set whose intersection is empty and is exhaustive. In this case, if we are saying that A is not intersecting with A complement, which is always the case, and they also are going to form the total set. So we can express the probability of B in terms of A and A complement as the probability of B given A multiplied by the probability of A plus the probability of B given A complement multiplied by the probability of A complement. So that's an extension of the Bayes rule in which we express the probability of B in terms of the law of total probability. So when can we apply Bayes' rule? So let's have an example, and the example is the same one from the last time, but in this case the question is different. So we have the three bags, bag 1, bag 2, and bag 3, and now the question is, if the chosen marble is red, so what is the probability that bag 1 was chosen? So the question is the probability of bag 1 was chosen given that the marble that we select was red. So we could try to do it in the traditional way. So we need to find the intersection of these two. We can use the law of total probability maybe, but we are going to use Bayes' rule. So Bayes' rule, so we express this conditional probability in terms of the swapped parameters. So we have, this is the probability of red given that we select bag 1 and that one is known, and then we multiply by probability of the second the first term by the probability of bag 1, and as usual we divide by the probability of being red. So now we have our results. So we have the probability of red given that we choose bag 1 is 0.75 multiplied by the probability of selecting bag 1, which is 1/3, and divided by the probability of selecting red, which we have that result from previous example, 0.6. So this is equal to 0.6. So the final result, the probability of choosing bag 1 given that the marble was red, is equal to 5 over 12.